Hello, everyone. First of all, until the presentation is uploaded, I wanted to thank the organizer committee and especially Yaniv, who took on these really difficult times in Israel. This is really an island of sanity here, so thank you so much. And I know that I'm the only one that stands between you and lunch, so I'll try to speak fast. All right, so today I will present our work in the past, I would like to say 10 years on dyslexia, and I will show some results from different neuroimaging modalities. Speaking for the importance role of cognitive control or executive function in reading and remediation in children. I will start with a short introduction about specific case of dyslexia and executive function, and then I will move on to our results on training that involves a stimulation of executive functions, and I will show some ERP results, bold and also functional connectivity. So a little bit about reading. Reading is the process of translating abstract shapes into sound and spoken language. It's not an intuitive process, although for most of us who know how to read, it comes very naturally. But if I tell you to focus on these letters really, really hard, if nobody teaches you what each shape means and what is the sound that corresponds with it, there is no chance in the world that you'll be able to do that. For some readers, like those with dyslexia, this is an ongoing struggle. So the definition of dyslexia as for today is difficulty in reading accuracy and speed. So reading is also non-fluent. That comes also with reading comprehension issues and sometimes with poor decoding and spelling. There are different causes for dyslexia. There is a major, sometimes debate in the literature, what is the main cause for dyslexia? We're not gonna get into this today. What I will say is that the core is phonological processing deficit, but there are studies that point at an additional executive function difficulty that may make this reading difficulty even more severe. So what is executive functions? Just shortly, it's an umbrella term for different cognitive processes that optimize performance and enable us to learn. It includes many of these sub-abilities listed here, and you see that there's a higher level and lower level. There are neuroimaging neural networks that support these sub-abilities, and in this very busy slide here from a recent lit review, you can see that the traditional models for reading that state that in order to be able to read, you just need to understand language and to know how to decode, and then you'll comprehend. We know today that this process is not as easy, and all these sub-studies here just say that executive function do participate in this reading process. What we also know is that in the specific case of dyslexia, there is asynchronization between the sensus modalities, so the visual and the auditory modalities during reading. For all of us, the auditory comes first and then the visual processing comes in. But in individuals with dyslexia, the gap between these two modalities is larger. And you can see it. See my pointer? You can see it here, both in the linguistic modality and also in non-linguistic tasks. So this is not something that is specific for language. This gap is related to slow speed of processing. So these readers are generally slower than others. There are some mechanisms that point to this. One of it is the neural noise theory, but I'm not going to get into this. So our research question was, will training reading while also triggering executive function will increase the synchronization between these visual and auditory modalities? How are we going to do this? So we develop a reading intervention, a computerized reading intervention that deletes the letters from the screen, as you see here. It does that initially in the child's own reading speed, but then, and it monitors comprehension during this process. And if the child comprehends the sentence based on the question that appears afterwards, then the letters are being deleted faster. How much faster? 5% faster, and then this is the new reading speed of the child. And when the child continues reading fluently and understand reading, then it speeds it up a little bit more and more. This training period took place for 8 weeks, 3 times per week, for approximately 20-30 minutes per training session, and they read 50 sentences. This is how the training package looks like, and they trained on this little Readly creature. Let's move on to the methods. So the children in the results that I'm going to show you are 8 to 12 years old kids. All of them are English speakers. I will show one slide on Hebrew-speaking children, just that you see the replicability of these results in different languages. The IQ was average above average. We had a definition for dyslexia based on these criteria, and we did not enroll in these studies that you're going to see the results soon. We did not enroll children with attention difficulties because these children specifically show that they're known to have an executive functions deficit. So for this study, we did not enroll any children with ADHD. So as I said, the EEG ERP results that I'm going to show you are based on a lexical decision task where the individuals see words and non-words and they need to push a button when they see this type of word versus a non-word. That was done in Hebrew. The functional MRI tasks that you're going to see are based on also lexical decision tasks because we wanted to replicate the results in Hebrew, resting state data, fluency data, and resting state-like data that was composed on many data sets from previous years that we concatenated into one large task, and we regressed out the task time series. And the training period was, as I said, for 8 weeks, 3 times per week, and we collected reading and executive functions data before and after training. So let's move on to the results. Behaviorally, we found that reading speed was significantly faster in both children with dyslexia and in typical readers. So you can see here the results for children with dyslexia and typical readers. Reading comprehension was significantly higher after training in children with dyslexia and remained the same in typical readers, probably because they started at the ceiling level. In the executive function domain, we found an improved executive function in different subtests that we used. I picked 2 here just to share some of the results with you. We found an increased visual attention abilities using the Sky Search. If someone is familiar with a Sky Search task, in both typical readers and in children with dyslexia, and improved naming abilities significantly only in children with dyslexia. A couple of words about the lexical decision task in the ERP results. As I said, we replicated these results and this whole study design both in Hebrew and in English. These are the results in Hebrew where we used EEG before and after training and not fMRI, and what you see here is a marker for executive function specifically for error monitoring. It is called error-related negativity. It appears right after the response, and what we found is that after training, this is the results before training and after training, the smooth line represent the amplitude for the error-related negativity on average across participants, and we found a significant increase of the ERN from before to after intervention. And not only that, the delta, the change between the error-related negativity and the brain signal for correct responses, which is the correct related negativity, was significantly higher in children with dyslexia versus typical readers. And this change was also related to better reading improvement, which was, or a higher gain, more accurately. These are the results for the bold data in children with dyslexia in English, again for a lexical decision task with a mini blocks that we created for words and non-words. And briefly what you see here is the contrast for words versus pseudo words. You see diffused activation before intervention. This is only for children with dyslexia. Diffused activation in the left and right hemisphere. And following intervention, we see more focused activation in the left hemisphere and visual processing and phonological processing regions, and a signature here in the right hemisphere in the occipital region. We then focused on executive function specifically, and we looked at the resting state condition for 18 individuals with dyslexia, and we found that when focusing on the singular opercular network here, based on the coordinates taken from Dozenbach study on cognitive control networks, we found a significantly increased functional connectivity after training, which was also correlated with greater fluency abilities in these readers. We then decided to look specifically at fluency task, and then we ran this manipulation that I showed you earlier for this intervention in the scanner. So you see here the study design. And then we found that individuals with dyslexia showed increased functional connectivity between the singular opercular network and the right visual cortices. That increase was also correlated with increased speed of processing and increased visual attention in these readers. And then above and beyond a specific task, when we concatenated the data from previous studies and new studies enrolling 126 children for about 30 minutes of usable data, we found an increased functional connectivity between the auditory and singular opercular network, as you see here, that was related to better reading fluency, as well as increased functional connectivity within the dorsal attention network and the frontal parietal network, both related to improved reading fluency. So with that, we did not find a specific increase between the visual and auditory modalities that was related to better, related to increased functional connectivity within the executive functions network or the singular opercular that we focused here. But we did find increased functional connectivity between each of the modalities and the executive functions network. This is still under examination, and this is our next step. So to conclude, the attention network that includes executive function is related to reading fluency in both typical and atypical reading development. We see that training shifts the activation to the left hemisphere and engages neural circuits that are related to attention and executive functions with visual processing and auditory regions. We see that also the effect is not specific to a reading task, because we found it also in resting state data. Maybe it's the main general. Can it be actually that this kind of reading transfers to math, maybe? This is something that we're looking at. And the next step is to try use other computational methods to group all data together, such as the fusion map, like my student Carmel Gashri that presented here 2 days ago. We would like to look at reading fluency in the scanner and to actually map the different characteristics of fluent speech in the scanner to test the same exact paradigm, and then to look at event-related voice-based fMRI data. And theoretically, we see that executive functions do have a role in reading. We think of maybe even boosting them or warming them up before reading training can improve the gains that children can get from this type of training. And we develop short games that I don't have time to talk about today, and also maybe add some additional populations to this study design. So I would like to thank the team. I would like to thank, I didn't show the Hebrew-based results here in this talk because it's so super short, but we are running for the past 3 years studies, neuroimaging studies here in Israel in the Strauss Center, and I could not do that without the amazing help of Daniel and Yaniv, so thank you so much, and thank you for your attention.